Hi friends, welcome to Unit 2, Day 1. In this section we're going to be focusing on relations, functions, and graphs. This one talks about the rectangular coordinates. That's the coordinates that you're probably most familiar with the Cartesian plane. Graphing circles, and then also graphing some other relations. So first let's talk about a relation. A relation is just a correspondence between two sets. Similar to a relationship is the kind of the function between two people. A relation is the correspondence, or how two things relate. So we can either write it in a set of ordered pairs, or we can also write it in equation form. When we have a domain, domain is all of the x values, the possible x values. And then the range is the possible y values. So for here, let's jump into example 1. Graph each of the following by using ordered pairs to satisfy the equation. So this is actually going back to some different methods than you're used to. Even though this is written in slope-intercept form, we're actually just going to plug in some values for x because it's written in terms of y. So if it's written in terms of the variable, then that means you want to plug some values into the other variable. So this is y equals, we're going to plug in some values for x. I always say if you don't know a good place to start, -2, -1, 0, 1, and 2 is a good way to go. -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. 2 minus 2 is 0. And then I'm going to go ahead and plot these points on my graph. -2, -4 is here. And then here are the rest of the values. Then the next thing you want to do is grab a straight edge because this is a line, so we're going to graph it using a straight edge. Whenever you're graphing, you want to use a straight edge if possible. If there's something that's preventing you from doing so, like technology or just the resources that you have, know that you could kind of like fold a piece of paper in half and do that instead. So there we go. So there is our graph. For letter B, 1b, this one is in terms of x. So we're actually going to plug in values for y instead. Now instead of writing it like this, where you have y on the left, we're still going to write y on the right because it helps us when we make our ordered pairs. But it's useful to know that we're talking about this in terms of y. So when I pick my values, I'm actually going to pick them for y instead. So -2, -1, 0, 1, and 2. I pick negative values that are small because it helps me see if the graph does anything with negative values. Pick 0, that's a good point, and then 1 and 2 just to kind of get a good spread. Sometimes that's not enough and you need to graph more. Most of the time for these basic graphs, we can just see the shape. So -2, if I plug in -2 for y, well that value that I get is going to be a +2. -1 is going to be a 1. 0 is 0. 1 and 2. So now if I graph these, I see that I actually have two values here at 2. I have one at -2 and one at +2. Similarly with 1 and similarly with 0. A lot of students have asked in this kind of example why we get this kind of shape. And the reason is we actually get kind of an absolute value shape. But if you notice, the absolute value shape is a V that opens upward or opens downward. This opens to the right. And that's because it's written in terms of x equals, not in terms of y equals. If this was written in terms of y equals, then it would open up or down. Also, if we had a negative sign in front of the x, then we would end up with it opening to the left instead. And then similarly, example 2, graph the following functions by making a table of values. This one is also going to give us very similar results. However, I noticed that I'm starting to get to higher powers or degrees. This is a quadratic. This is written in terms of y equals, so then when I set up my table, I'm going to use -1, -2, -1, 0, 1, and 2 on my x side. If I plug in -2 in, -2 quantity squared is 4, and then 4 plus 4 is 8. -1 squared is 1. 1 plus 2 is 3. 0, that gives me 0. 1 squared minus 2 is -1. 2 squared is 4. Minus 4 is 0. There we go. So this looks like it's starting to make that quadratic shape. -2, 8 is just off the graph, I believe. 1, 2, 3, 4, 5, 6, 7. Yeah, just off the graph. I don't make extra lines. That's a common mistake students make. What you can do is you can just go by a different scale if you feel more comfortable doing that. But don't make extra lines. That is incorrect. If you look here, I can kind of see that it's making this quadratic U shape. You should know from previous courses that then it's going to reflect. This is your axis symmetry. It should reflect across here. I'm not getting a straight edge for this. Because it's a quadratic, it's U-shaped, I know that it's going to be more like this instead. Make sure when you make your quadratic, you make a flat down here at the bottom. And then there we go. So that's going to be your quadratic. Now the next one, B, y equals the square root of 9 minus x squared. Again, it's y equals, so when I plug in my values, I'm going to use -2, -1, 0, 1, and 2. If I plug in -2, so let's see, plug in -2, -2 quantity squared is 4, 9 minus 4 is 5, -1 quantity squared is 1, and then that's 8. It's going to be 0, 9, 8, 5. In fact, if I go just one farther and I do -3 and 3, I get 0 and 0. This is, as you graph it, you'll notice that this is kind of what looks to be like an arc or a semicircle. And it is, so that, 1, 2, 3, 4, 5. All right, so knowing that this is going to go off the graph, I'm going to change my y value. So instead of going up by 1s, I'm going to have it go up by 2s instead. Because I'm changing this grid value, I'm going to go ahead and label 2, 4, 6, 8, 10, 12, 14. That way you can see it's going up -14. So that way it's going up by 2s. All right. -2, 5 is here. And then -1, 8's here. 0, 9. And then it goes back down. Now earlier I said this was kind of like a semicircle. It's a very squeezed in semicircle, so it's kind of hard to see kind of what's going on here. And then I changed the values of the range. I changed the intervals that we're doing here, so just kind of heads up on that. So yeah, going through, we can see like this value begins, like the lowest value I'm going to have is at -3. If I go any farther, -4, I'm going to end up with a negative under the radical. So this is literally the lowest value that it can go. And we're going to talk about, for this one, we're going to talk about domain and range with these problems. We're going to come back to that after we finish C. So with C, I've got x equals y squared. Again, it's x equals, so I'm going to change the values. I'm going to change where I'm plugging them in. I'm going to plug them into my y side of my table instead, because this is in terms of x equals. -2 squared gives me 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And then 4. So again, I have values here for -2, 1, 2, 3, 4. So that's here and also here. So again, we're getting a kind of a sideways parabola, similar to what we would have, vertically up and down, that U shape, or upside down U shape. This is instead opening to the right. And then this as well. Okay, so with these problems, we can actually start talking about domain and range with a little bit more fidelity than our previous page. If you look back on our previous page, these here, this one here, the domain and range is going to be all real numbers. Domain, all real numbers, and range is all real numbers. And remember, we can talk about this in different ways. We can also talk about this in set notation. The set of x's such that x is an element of the real numbers. We can also talk about this in interval notation from -infinity to infinity. So those mean the same thing. Down here in the bottom with example B, if we look our domain values, we actually get to a certain point where we can't have a negative domain. So for here, our domain would be all real numbers greater than or equal to 0. So with this one, we have to be careful. We can't just say all real numbers, period, but we can say all real numbers greater than or equal to 0. So then also similarly, if I was to write this in interval or set notation, the set of x's, such that x is greater than or equal to 0. And then as an interval, 0 to infinity. Or maybe multiple ways that I would ask that. Range for this one is going to be all real numbers. On this side, now we can start getting a little bit kind of selective. For this one, I can have any value for my domain. So my domain is going to be all real numbers. I'm going to abbreviate and put just all real numbers for when the domain is such that, but just know that I could ask for any form. Range. If I look, my minimum or my lowest point on this graph is going to be at -1. So my range is going to be from -1. It looks like this goes up, so this is going to be -1 to infinity. Again, I could use any notation or form for this. B, this is where things get different because we're actually restricting both the domain and the range. So the domain for this one, I go from -3 to 3 inclusive. And then the range, now be careful because we changed our values. So I'm looking here, I see that it's 9. So it's going to be from 0 to 9 inclusive. And then here for this last one, for C, we've got domain. Again, I can have negative values, so it's going to be 0 to infinity. And then the range, looks like I can have any value I want. So all real numbers. I would go through and practice writing these in the other formats, the other ways. So like set notation, set notation, and then set notation for these as well. I just did interval for these, so that would be a good way to start. Thank you for joining me in this video. Join me in the next one where we talk about circles. Have a great day.